How are you, everybody? Just trying to get some practice here with my program here, the OBS, so I can combine certain cameras and audio features and to see if I can actually go live on YouTube one of these days. So what I'm doing here for practicing this stuff is that I'm putting together this hybrid sensor. This sensor is from a C111 machine that is the Hunter first computer-based aligner or microprocessor-based aligner back in the 80s, and I've been using this machine forever. I was trying to get to use G111, or I had this one, a G111 that somebody gave me, and I had it in there for a while. It was working when I got it, supposedly, but it was no way to calibrate it because the calibration for that machine requires a calibration board and special prisms so you can perform the calibration. Also, you require a fixture so you can mount the sensors to the fixture, and then you use that calibration board and put it on the machine, and then you can it gives you the calibration option on several sensors, and the optical type of sensors and on the hybrid sensors. So the optical sensors are these kind of sensors. They got the optical part without having to get it mounted into a mechanical arm like this one. This one is got, that's why it's called hybrid, because it's got both the mechanical and the optical in the same sensor. In my opinion, it's pretty good. I mean, it does the same thing. So I couldn't actually make it work. I ended up having to reconfigure the sensors to be used on the G111, and they worked just fine, but they were very dirty. These are the sensors that were so dirty. Took everything apart from the sensor, and that's why I'm putting it back together here. Alright, so that's why I'm putting it back together. As you can see, this is the electronics for the sensor itself. It's based on some microprocessor right here. This gathers all the info from the sensors, and it decodes it and send it serially to the main board on the C111, or say the D111, the F and G. That's what I'm doing here. I'm going to put it together, and these three sensors, actually, the wheel position sensor has got a couple of infrared receiver and transmitter here, and it's got the camber sensor, and it's got the toe sensor with the optical part. Alright, so how does the sensor know what angle is going to be tilted and transmitted to the main board? Well, it's got a glass bulb here filled with some electrolyte and some probes inside that change the exposure to that electrolyte, changing the resistance and thus the voltage, and that gets interpreted and digitized and sent to the main board. So when you tilt it one way or the other, the fluid remains level, and the exposure on those probes changes. So that's how it detects the angle. The later optical sensors that I'm showing you, and I open this one up here, it's got this magnet here with some windings and a little lever here with an optical transmitter receiver here. The movement is very limited. It's because we're talking about a range of maximum 10 degrees on caster and maybe 2 degrees on camber. When we get our phone and we get the compass here, and then it's divided in 360 degrees, right? Then we get also a level, and it changes from 0 to whatever angle, right, in 1 degree increments. I don't know if there's one sensitive enough to go not in 1 degree increments, but in like 1/10 of a degree increment, which is required for the alignments. The alignments, you might say, well, the iPhones will do that automatically. Yeah, but this will go, we work and within 1 degree most of the time. So we'll go by 1/10 of a degree to 10/10ths of a degree, right? One degree. So it's incredible that an automobile requires so much precision so the tires won't wear excessively on the tires. So, and then that you could actually do the adjustment through either ball joints, tie rod ends, bushings, or whatever, to be able to match that angle. Of course, the most critical angle that causes tire wear would be the toe, and also on the toe with this detector will actually change there's an infrared LED. There's an infrared LED here that shoots the infrared light to this infrared detector, and since it's got some shutter right here and a window, it reflects only in certain parts, and as it's rotating about that lens, then it changes the exposure on the receiver, and it changes the voltage with get registered with this chip and sent to the board and interpret as an angle changes. Now we're talking about also tenths of an inch or a degree reading that you can actually tell the machine to do or to register or to get. So this is how these sensors kind of work. And as you can see here, I had to take and straighten out and paint so I can put everything together and it look good and look presentable. But the main thing is that I can actually calibrate and make useful again. So since the optical sensors are so hard to repair, hybrid sensors are easier and easier to calibrate also. Then I'm gonna keep an eye on them, and maybe I can start restoring these machines as long as I can get them. So I'm gonna keep the calibration board that I just got and trying to keep doing this stuff for this kind of machines, C111 and G111. All right, so basically this is what I was trying to get to with this video. And when you start with something new, it's very hard to master. You have to practice it. So I hope you don't mind. Don't unsubscribe, please. Just be patient. And just talking about these sensors, because on my channel, it's supposed to be about CNC stuff, but also what crosses my mind, my shop here. So I used to be an alignment guy, so I'm talking about alignments too. Hopefully there will be interest on this stuff, or if not, well, YouTube will throw them away. So if you like the video, just give it a like. If you want to subscribe to the channel, just I'll thank you very much for that, and I will see you in the next video. Bye bye.